In 1994, I was working as the Quality Control and Industrial Engineering Manager for a ceiling grid manufacturer in Maryland. Now, we had a second factory also in Pennsylvania, and that's where the corporate center was located. When we brought the two plants together in a joint venture, we were the number 4 largest ceiling grid manufacturer in the world, but we had aspirations to become number 1. So the corporate group decided that the way to do that was to expand globally, and they picked a site in northern France to build another factory. I was given the responsibility to create the specification drawings and quality assurance information and training for all the new products that were going to be produced in France. So I spent a number of months doing that, and in the meantime, the company was developing some breakthroughs around the ceiling grid they were producing. Now, ceiling grid is used as a framework and a structure for putting ceiling tiles in, along with light fixtures, vents, and other accessories in the ceiling plane. When done well, everything looks like it fits there, square, level, everything is flat, and pretty much you don't notice a whole lot in your ceiling, but a lot of good things are going on there. The breakthrough that they created was a thing called stitching. So ceiling grid is usually made out of coil steel that is folded up to kind of like a T, and a cap or color is put on top of it, so that's what the person sees in their ceiling. But sometimes that metal isn't as strong as it needs to be, and if you're installing the grid, sometimes the bars will twist. So the company figured out a way to reduce that twisting and make the bar stiffer, and they created a thing called stitching. And what stitching did was it basically brought those two pieces of metal together and basically joined them in such a way that it looked like a sewing stitch. It forced the metal to go one way and then the other and the other and the other, and so it actually made the metal stick out from side to side right where the stitch was. Again, looking just like if you were sewing some clothing together. So I did all the drawings and flew to northern France, where I was met by a bilingual intern. And my job during my time in France was to teach him how grid works and develop the training with him so that it could be delivered to the French-speaking technicians working there. So the first thing that I knew I needed to do was teach him how grid works. So I didn't have an installation area in this new plant. The plant wasn't fully built at that time. They were just trying to run some products to see if they could. So we decided to use the floor as our ceiling. So the first thing I did was I put a 12-foot bar of grid down on the floor with the face side down and showed him the holes in the connectors that were built into this bar. Then we took 2 4-foot bars of grid, and they were designed to go through the hole and connect to each other through the hole to create that 90-degree angle that would allow the tile to sit within. So I put the first bar through the hole. I said, this is how it goes through. It goes through just like this. And I took the second bar and I tried to put it through the hole, and I said it's supposed to go through the hole just like this, but it wasn't making it through the hole. I couldn't figure out what was going on because grid typically, they both fit through the hole, they connect, and you have a nice strong structure. What could be going on? So I took that bar of grid out, I turned it 180 degrees and put the other side in, and it did fit. Well, what was going on? So we verified that 33%, 1/3 of all the grid wasn't fitting through the holes when both pieces were put through. Well, that's an unacceptable scrap rate. You certainly can't have that. It turns out that the stitch was also in the ends that were trying to go through the hole, and it was making the metal look like it was thicker than it actually was, and it wasn't fitting through the hole. So if the stitch was in the wrong place, those two ends wouldn't fit through the hole. Well, that's a problem. The bigger problem was this was the day they sent out their first shipment of ceiling grid. And there was much celebrating. And in France, celebrating is done by telling of speeches and clapping of hands and pouring of champagne in the factory. And everybody was quite happy, except me. So I knew what I had to do. I had to go find the plant manager and I had to inform him of what was going on and that we had to turn the shipment around. So he didn't like the news that I had for him, but he knew the right thing to do was to call the customer, apologize for the delay, and definitely turn the shipment around before it got to them. So we now knew what the problem was. We had protected our customers. Now we had to figure out what to do about it. The good news is we had really experienced engineers and mechanics at the plant, and they were able to redesign the grid so that the stitch could not be on the ends of it and all the grid would fit through the holes. During the time that they were reconfiguring the production lines, I was able to work with the bilingual intern, and we basically trained every single person in the plant to become grid installers so that they truly would know their product they were making. Used a technique called tell, show, and do. So I told them how grid works, I showed them how it worked, and then I had them demonstrate they could install grid. By the time that was over, we had competent and confident grid installers that could protect the interests of their customers from then on. And the good news is we did. The company grew and became the #1 provider of ceiling grid in the entire world. And that's what happens when you make things to the benefit of your customer.
I hope this story provided you with some inspiration to revisit your own processes. I have a lot more I'd like to share. Head over to pi-partners.com to learn how I can help. And check back from time to time for more Kaizen stories.